So this question number 12 from linear algebra. So I have gone through the linear algebra questions, and those questions were good and conceptual, and yeah, it was very close to my lectures. So anyone who have gone through my lectures on linear algebra, that is already available on YouTube freely. So they might relate that it is very close what we have gone through the chapters. But yeah, I was talking about this question number 12. So it seems like some information should be there, or kind of ambiguous question. So maybe you can interpret differently. So let me first of all explain what it is asking. So it is asking that the number of additions and multiplication involved in performing Gauss elimination on n by n upper triangular matrix is of the order. So you will have to carefully observe the words they have written. So performing Gauss elimination, so they just have mentioned the Gauss elimination, right? So let me give you idea what we do. We have some matrix A, right? And maybe we could have a system of equation that is A times x is equals to B. What we do, we perform the Gauss elimination and we convert this. At the first step, what we do, we do the elimination, and that was given by the Gauss, so that is why we call it Gauss elimination. So we do some Gauss elimination and we convert this system of equation to some upper triangular matrix times this x is equals to some right hand side C, right? So far what we have done, we have just applied this Gauss elimination, and once we have this system of equation, then we will have such n equations. And next step what we do the back substitution and we solve for x, right? So in order to solve this ax is equals to b, what we do Gauss elimination plus back substitution, right? Now let me go through this question. What it is saying, that the number of addition and multiplication involved in performing Gauss elimination of any n by n upper triangular matrix is order of. So if you have already upper triangular matrix and if you apply the Gauss elimination on it, right? So I mean, you do not even have to apply the Gauss elimination. It is already in upper triangular, right? So how many operation you need to do? None operation, right? So big O of in constant time you can do it, right? There is no option that is of big O of 1, right? But I think maybe their intention was to give this question with Gauss elimination plus back substitution. So they need to mention that performing the Gauss elimination and back substitution, right? So in back substitution, the number of, like, the addition and multiplication that you will be performing will be order of n square, right? Because you will have, so this is n by n matrix, right? So at the end you will have an equation, right? Something like this, if you have already gone through the process, right? At the end you will have something z is equal to some constant, and what you do, so for this equation you do not have to do any addition, any multiplication, right? So 0, and above this equation, this is the equation, right? This will be kind of something like this: 2 times y plus z is equal to some 3, right? What you do, you put the z here, right? And you find the y. So here, maybe here 2 times z, so here you will do 1 multiplication and here is 1 addition, right? So here you will, total operation will be 2, right? Again, if from here you will get the y, and from here you have already get the z. So what you will do, you will put these two value into here. You will find, so putting this y and z, that means doing some multiplication with constant. So there will be 2 multiplication and there will be 2 addition. So 2. So overall point is that you will, for the back substitution, you will need to have multiplication and addition that will of order of n squared, right? So if their intention was to ask that performing the Gauss elimination plus with back substitution, then obviously that in that case the answer would be big O of n squared, right? So I think from my perspective, from my point of view, the question is not clear, right? Many would have thought it would be big O of 1, since it is already in upper triangular and you do the Gauss elimination. You do not need to do the Gauss elimination, so that this is just a constant time, right? Yeah. Or in general, if you have some n by n matrix and you do this Gauss elimination, so you will do for each row, right? So that will be order of n cube. So just for doing the Gauss elimination of any general n by n matrix. So we will go through these points in our lecture. But yeah, this is the view for this question number 12. So let me know what you thought, and maybe possibilities that you can challenge this question, being the ambiguous or having the different interpretation based on these wordings, right? That is all. We will do, I think, since answer key has been already released, so we will go through the paper. I have already gone through the linear algebra question, and the questions were very good, and the conceptual questions, and it really demands that you should be good in concept, not just like going through the matrices and just like remembering the type of matrices, and you need to have the actual picture of the linear algebra that I have already covered. Okay, that is all. This question number 12. Let me know in the comment that what is your thought on this question. Thank you.